Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 35 of our complete DevOps course, and in this class we will try to learn about Kubernetes services. So service is very critical component of Kubernetes. So in like I told you, in production scenarios, we don't deploy a pod, but we usually deploy a deployment, right? So this is what we learned in the last class. So this is our learning from the last class. Similarly, once you deploy a deployment, for each deployment, most of the times you will create a service in the world of Kubernetes. So why will we create this service? And what is the importance of service? Let's try to understand in today's class. Okay, so before we learn anything, what we usually do is we'll try to learn the why aspect of it, right? Why do we need a service in Kubernetes, and what happens if there is no service in Kubernetes? Okay, so let's talk about the scenarios of no service. Okay, so now everything that I'm going to talk about is assuming that what if there is no concept of services in Kubernetes? Okay, so what will happen? So what will happen usually, like our previous classes, what a developer or DevOps engineer would do, he will deploy his pod as a deployment in Kubernetes, right? And what that pod will do, what that deployment would do, it would create a replica set. And what replica set would do, it would create a pod. If the pod count is 1, it would create a single pod, or if the replicas are multiple, then it would create multiple replicas. Let's say we have the requirement of creating 3 replicas. Okay, so assume this is replica 1, replica 2, and a replica 3. Why do we need multiple replicas of a pod? For a general understanding, let's say there is one user, then in such cases you don't need it. But let's say there are 10 concurrent users. Concurrent is people trying to use same time. Like for example, you and me might use WhatsApp at the same time. So like similarly, there can be some thousands of users who are trying to access WhatsApp at the same point of time. So if every request is going to only one particular pod, then this pod will go down because it is getting too much of load. So that's why what you usually do is you create multiple replicas, and the number of count of replicas depend upon the number of users trying to access your applications, and also number of connections one particular pod can take. Okay, so if somebody asks you what is the ideal pod size or what is the ideal pod count, what will you say is it depends upon the number of concurrent users and number of users or the number of requests one replica of your pod can, I mean one replica of your application can handle. So if one replica of your application can handle 10 requests at one time, and if you have 100 requests that are coming in, then you have to create 10 pods. Okay, so you have to take this decision as a DevOps engineer, as developers, you have to sit together and you have to take this decision. Okay, now if we don't deviate, let's say there are 3 pods. Okay, and now for these 3 pods, the problem is that let's say one of these pod has gone down for some reason. Okay, there is some network issue, or in the world of Kubernetes, in the world of containers, a pod going down or a container going down is very common. But what is the advantage of Kubernetes is because of its auto healing capability. Okay, so why we move towards Kubernetes is because Kubernetes has this auto healing capability. Containers are ephemeral, so if the containers die, they do not come up. Similarly, if a pod goes down, it will not come up automatically unless you have the auto healing behavior that is implemented by the deployment in Kubernetes or replica set controller in Kubernetes, right? Sorry. So now let's say you have the auto healing in place. So what happens as soon as this pod has gone down? What will this replica set say? Don't worry, I'm here. Let me create one more copy, and this copy will be created even before the actual one is deleted, or parallelly it happens. Okay, so I have this one back. But the problem is that when this one comes up, let's say previously the IP addresses were 172.16.3.4, 3.5, and 3.6. I mean 172, 3.4.5, something like that. And next time when it came up, the IP address will change. Previously, if it is 172.16.3.4, when it comes up, this time it might be 172.16.3.8. So what happened is, okay, the application came up, but the IP address of the application has changed. And now we are talking about the scenario where there is no services concept in Kubernetes. So what will happen is your application IP addresses, you have to share with your test team, you have to share with your other project who is using these applications or as third party applications or something. What they usually do is they'll try to access this application. Let's say there are three teams who are trying to access this application, or three people who are trying to access this application. What you said for user number one, this is the IP address, user number two, this is the IP address, user number three, this is the IP address. So as a DevOps engineer, you thought I created a deployment which created a replica set, which created three replicas of pods, and there are three users. So parallelly also, if they try to use, my applications are accessible because I created three replicas of the pods. And for one person, I said 172.16.3.4. For one person or other team, you said 172.16.3.5. And for the others, you said 172.16.3.6. So you are in an assumption that everything is right. But now what has happened? Even though you have the auto healing capability of Kubernetes, because the IP address has changed. So this is pod 1, pod 2, and pod 3. But the IP address is new, 172.16.3.8. So this user 1 or the project 1, let's say there are 10 people in project 1 who are trying to test this application. What they said is your application is not reachable or your application is not working. But as a DevOps engineer, what are you arguing? No, my application is there. I can see my application. You are doing something wrong. End of the day, you realized that after debugging, he is trying to send request to 172.16.3.4, but the IP address of your application is 172.16.3.8. So neither he is wrong nor you are wrong, because you have implemented auto healing and he said that I have used the same IP address that you gave. So this is the problem. And even if you look at the real world, okay, so the real world will never work like this. Let's say all of us use google.com on a day-to-day basis. Okay, will Google ever tell you that try to access my application on a IP address called 100.64.2.7? And for let's say there is another user, Google will say, okay, access me on 172.16.3.9. So let's say Google has 100 replicas. Now Google will never tell you that 1 million user access on this port, this particular IP address, another million people access on this specific IP address. That doesn't work like that. So what is the concept here? The concept is Google does a load balancing. Okay, and even I told you when I introduced you all to Kubernetes, so that there is a concept called load balancing in Kubernetes. Okay, and I'll teach you later. So what you will tell this user project 1 is, okay, do not access using this IP addresses. What you will do is I will create, like, you created a deployment for this. You will tell them that on top of this, I will create something called as a service. The shortcut for service is SVC. Okay, so I will create something called as service, and what you do is instead of accessing this specific things, okay, directly try to access the service. Okay, so what now the user project 1 team does is instead of accessing the 172.16.3.4, let's say there are three replicas, let's write all the IP addresses: 172.16.3.5 and 172.16.3.6. Let's say these are the three IP addresses that you got from Kubernetes clusters. And then there are three projects. One is user project 1, then user project 2, then user project 3. Previously, you were giving them these IP addresses and you are asking them to access the application using the IP addresses. But what was going wrong? When the pod was going down, you have the auto healing behavior, but the problem is that the auto healing behavior, when it spins up a new pod, the IP address was changed from 172.16.3.4 to 3.8. This can happen to this specific pod as well, and this can happen to this specific pod as well. So what you will do is instead of this behavior, instead of giving them each and every IP addresses, you can simply change this behavior by creating a service on top of the deployment. So if you say that this is a deployment that has created three pods using a replica set, on top of this, you will create something called as a service. Okay. And what this service does is it acts as a load balancer. How does it act as a load balancer? It uses a component in Kubernetes that is called as kubeproxy. Now let's quickly not go into it because you will get confused. For now, let's assume that service is doing it. Ignore about kubeproxy for now. Okay, so what service is offering is load balancing, and you will tell these 3 user projects that instead of accessing the IP address, and this IP address can change very frequently, so what you will do is access me using the service name. So what these people will do, or what these development teams will do, instead of accessing the payments applications on this specific IP addresses, they will say payment dot default dot svc. Okay, so let's say this is the name of the service that Kubernetes provided you. As soon as you create a service, what Kubernetes does is this is your name of the service, this is the namespace, and this is .svc. So Kubernetes will give you something like this, and you can tell them that okay, you can access my applications on this specific IP address, that is the service IP address or the load balancing IP address. So these people will try to access these applications on the same IP address. Okay, so everybody will use the same IP address. Underlying what this load balancer, what this service using kubeproxy will do is it will forward the request. Let's say 10 requests are coming from here, 10 requests are coming from here, 10 requests are coming from here. It will just say, okay, send 10 requests here, send 10 requests here, and send 10 requests here. So this is one problem without service you would have faced. Okay, so if there were no services concept in Kubernetes, you would fail terribly even implementing the auto healing capability. Even you have deployments and pods, your applications will not work for certain people. When the application goes down, it comes up with a new IP address, so there is a problem. And who is solving this problem? The problem is solved by service. So what is one point that we learned about the advantage of service? That is load balancing. Now you should immediately get a question from the previous explanation that I just showed you. You should get a question that okay, Abhishek, let's go back to the diagram once. I got it out. So what you should ask is, okay, let's say that you gave this IP address, I mean, instead of IP address you gave this URL to them. So service should also face the same problem, right? Because if user one project was not able to reach this specific pod because the IP address URL has changed, right? From 3.4 it has changed to 3.8. Now a service, what is it actually doing? It is just taking the request from this user and it is forwarding the request. But even the service should face the same problem because the IP address has changed. The service should be sending the request to 172.16.3.4, but the new IP address is 172.16.3.8, right? So you must ask me a question that, okay, Abhishek, even the 10 requests that service has sent to 172.16.3.4 would fail. And again, the problem is same. User project one who is trying to access this pod using the service would fail terribly, right? Because there is no traffic. So this is another problem that service solve, that is called as discovery. Okay, so what is it called? The second advantage that you get using service is service discovery. So what service says is, okay, I understood the problem that if I am keeping a track of a deployment, okay, let's say this is service is keeping a track of deployment and which is creating 3 pods, for example. And if one of these IP address is changed, let's say this IP address has changed. If service also follows the same problem of keeping a track of IP address, the problem is not solved at all. So what service said is, okay, I'll not bother about IP address at all. Okay, I will come up with a new process which is called as labels and selectors. Okay, so how service does a service discovery? Unlike the previous example that I showed you, unlike manually keeping track of IP addresses, which can change any number of times, okay, and even if there are 2 to 3 pods, let's say service can keep track of IP addresses. What if there are 1,000 pods? This can happen. Like companies like Google, they might have 1,000 pods. Okay, I'm just giving an example. Or they can have some 50 to 60 pods. So if service manually keeps track of all the IP addresses, then this problem will arrive. So that's why what service said is, I'll introduce a new mechanism called labels and selectors. Okay, and what these labels and selectors will do is, okay, for every pod that is getting created, DevOps engineers or developers, what they will do is they will apply a label. Okay, so this label will be common for all the pods. Let's say this is payments, right? So you can create a label for each of these pods called payment. Now what service says is, I'll not bother about IP address. I will only watch for the pods with this specific label called payment. Okay, so this can go down 100 times or this can go down 1000 times. I don't bother about it because I'm only watching about label. So next time if this goes down, and this can come up with a new IP address, but the label will remain the same. Why will label remain the same? Because the replica set controller, what it will do is it will deploy a new pod with the same YAML that it got, right? That is auto healing. So if a service is keeping track of your pods using labels instead of IP address, and the label is always the same, the problem is solved. So this is the service discovery mechanism of Kubernetes service. So how Kubernetes service will do a service mechanism? Using labels and selectors. Okay, so this is why Kubernetes service concept is advanced. Okay, why Kubernetes service has a very good service discovery mechanism is because of the concept that it uses, which is called as labels and selectors, right? I hope you got this answer. Let's go back to the previous slide to make it even clear. So what service will do is, okay, I'll draw a new diagram probably. So the end mechanism would be, you create a deployment. Okay, so this is your deployment. And how do you create a deployment? Basically, you create a YAML manifest, right? So let's say you created a YAML manifest. What as a DevOps engineer you will do is, whenever you create this deployment, okay, so you provide all the specification that is required and all of the things. Along with that, inside your metadata, okay, metadata of your deployment, you create something called as a label. Label is just a tag. You can just say app payment, for example. So now what this deployment will do, it will create a replica set. And what this replica set will do, let's say there are two replicas, it will create pod 1 and this is pod 2. And for both the pods, it will have a label. Like a pod will, if you just do kubectl edit pod, you can see the pod, right? Or you can do kubectl describe pod and you can see the pod. So what you will see is, for this pod there is a label called app payment. Similarly, there is also a label here called app payment. Perfect. So let's say this service has gone down. I might be repeating this multiple times, but this is very important. Let's say this pod has gone down. So the IP address will change. But what will replica set say? Okay, I have the YAML manifest, and according to the YAML manifest, the pod has to be created with this specific label. So even if this is going down 100 times it will come up with the same labels and selector. Now what we will do from today's learning is, we will create a service, right? Because service offers a load balancing that is required. Along with that, what service is also doing is, instead of looking or keeping track of IP addresses, it will keep track of this label. So whenever a new pod is created, let's say you increase the replica from 2 to 3 also, so again a new pod will be created with label app payment. So service will understand, oh, okay, there is a new pod, so I have to keep track of this as well. So this is how service maintains a service discovery process. So this is very important. If interviewers are asking you, you should be able to answer this. Okay, so this is the concept of labels and selectors. Perfect. First one we learned is load balancing. Second one we learned is about service discovery. Let's learn about the third thing. So the third thing and the other important thing, what a service can do is, any guesses what a service can do apart from this is, it can also expose to external world. Now, what is this another thing that I'm going to talk about? Don't worry, we will do practicals and we will do demos of each and everything. So even if in case in today's theory you are understanding few things and you are waiting for the demo, don't worry. In tomorrow's class, we will do a detailed demo of service. Okay. So I just don't want to hurry up in the theory and move on to the demo part, because practicals are as equal as your theory. So if you understand theory very well, then practicals you will able to understand very easy. So we talked about two things. If we see here, I explained already two things, and I hope these two things are clear: load balancing and service discovery. Now the third thing is exposing your application to the world. What is this? So yesterday's class, what we have seen is whenever we are creating a deployment, right? The pod that got created, what has happened to this pod? This pod came up with a IP address 172.16.3.4. Okay, whether you are accessing this, directly by SSHing into the minikube, or you have created your Kubernetes cluster and you have SSH to the master or any worker node, what is actually happening is whoever has access to this Kubernetes cluster, right? It can be minikube, it can be cops, it can be EKS, anything. So whoever has access to this, they can log into the Kubernetes cluster and they can hit the application. But this is not a real world scenario, right? So you cannot ask your customer that, okay, SSH to my machine, log into Kubernetes and access my application on this IP address. Will Google ever tell you this complicated process? So google.com, you are anywhere in the world, you don't require SSH or you don't require anything. You directly access your application on https.google.com, right? So this is what you try to do. So this is something that Kubernetes cannot offer you directly by using deployments. So deployments can create a pod and a user can SSH onto your Kubernetes cluster, then SSH into probably master node, worker node, and they can, access the application. But for end users, somewhere your user might be sitting in, somewhere in Italy, or he might be sitting somewhere in Austria. Now you cannot tell him that, okay, you cannot have access to my application directly because you are not in my network. Firstly, you have to come to my network, use VPN. You cannot say all of these things, right? So what service will do additionally is a service can expose your application. Okay, so by expose your application is service can allow your application to access outside the Kubernetes cluster, right? Outside the K8s cluster. So how service will do it is basically whenever you are taking a Kubernetes service, you are provided with three options. Okay, we will see that in live. Don't worry. Like I'm telling you, whenever you are creating a Kubernetes service resource in the YAML manifest, what you can say is you can create this service of three types. Type 1, cluster IP. Type 2, you can create it as a node port mode. Type 3, you can create it as a load balancer. There are other types as well, headless service and all. I'm not talking about all of those things. Okay, so these are the default types. So cluster IP, node port, and load balancing. So what happens is if you create this service using a cluster IP mode, any service, so this will be a by default behavior. So your application will still be only accessed inside the Kubernetes cluster. Nothing will change for you. Only if you create a service with this cluster IP mode, what happens is you will get the two benefits that we talked till now, that is discovery and load balancing. Okay, what are you getting? Discovery and load balancing. But if you create service of type node port mode, then what service will do is it will allow your application to be accessed inside your organization. Okay, so anybody within your organization or anybody within your network who is not, technically they might not have access to the Kubernetes cluster, but they have access to your worker node IP addresses. Okay, so if I have to just put it in a very simple way, whoever has access to your nodes, node IP addresses, only they can access the application if you create your service as type node port mode. Okay, and finally load balancer type. So what is load balancer type? So load balancer type is basically your service will expose your application to external world. Let's say you have deployed these, everything on a EKS Kubernetes cluster. So if you are creating a service of load balancer type, then you will get a elastic load balancer IP address for your specific service. And whoever is trying to access, they can use this elastic anywhere in the world because this is a public IP address, right? So they can access using the public IP address. Got it? So like I was telling you previously, payments dot default dot svc. So this is your, you know, the service name, or this is your this is where your service get resolved. But when you create a service as external world or load balancer, service type of mode load balancer, then if it is on any cloud provider, then depending upon the cloud provider implementation, this load balancer will only work on cloud providers. Okay, so if you are trying to do it on your Minikube, or if you're trying to do it by default, it will not work. Okay, so there is a project which is trying to get this work on the Minikube as well, but for now let's not go into the details. If you try to do by default on Minikube or any local Kubernetes clusters, the service type load balancer will not work. So what is the solution there? That we will learn in future classes there, where we will learn about ingresses. Okay, but if you create load balancer service type, then that means to say on your cloud provider, there will be a elastic load balancer IP address that will be created, which is the public IP address using which you can access your application. Okay, if you create it as a node port mode, then you can access within your, whoever has access to your AWS, or whoever has access to your node inside the AWS, they can access your application. Cluster IP, nobody can access. Whoever just has access to Kubernetes can access this thing. Now I'll explain everything in one simple diagram so that you will understand it in a much clearer way. So let's say this is your entire Kubernetes cluster. What you have done is you created a deployment. Replica set, pod. All of these things is inside a node. Okay, let me, this is pod. Okay, now let's assume all of this is inside a node. This is worker node 1, for example. This is your Kubernetes cluster, which has assumed 2 to 3 nodes. Okay, but for easy understanding, I did not draw all of them. Now there is a customer. Okay, so what you will do is, on top of this, like I told you, you will create something called as a service. So service will watch for the pods. Now let's try to understand the customer's flow, or let's try to understand the user flow depending upon the type of service. If you create this service as a cluster IP service, this is case 1. You have created this as a cluster IP. So what will this service do is, if you create this using a cluster IP mode, then this service will say, okay, don't worry about anything. The application should be accessed only for the people who has access to this Kubernetes cluster. So there is a customer, or there is a user who is trying to access this application. He is sitting outside your organization. Okay, so let's say this is public and this is your organization. Something like you are using your home Wi-Fi and he is using his home Wi-Fi. Very easy understanding. Okay, so this is public and this is your organization. So he tries to reach, but he cannot reach this specific thing. Let's say he has access to the organization as well. He cannot reach the application because the problem is the application is sitting somewhere here and he do not have access to this specific thing, right? So that is not practically possible. Now let's say you have created a load balancer type service. What will happen is, the service that got created, it will say if you assume this cluster is on AWS, it will notify AWS that, oh, I mean, Kubernetes API server will notify AWS that, okay, EKS, I have a service of type load balancer mode. So can you give me a elastic load balancer IP address? Okay, which means a public IP address. And which component of Kubernetes is doing it? There is a component in Kubernetes that we learned that is called as Cloud Control Manager. Right? This is part of your Kubernetes master node. What is this component? Kubernetes Cloud Control Manager. So the Cloud Control Manager will generate a public IP address using the AWS implementation, and it will return a public IP address. And now what service will do is, it will say whoever wants to access these pods, you can access using a public IP address. Okay, so this is the public IP address. So this public IP address, by the name itself, it's public, so that anyone who has access to internet, you just need to have access to internet. So user who has access to internet can access the application because the service type is load balancer. Finally, you have something called as node port mode. So when you create a service of node port mode, then whoever has access, like this is the public, right? Or this is the user. Now he only has access to public internet, or he only has access to resources in the internet. But what a service type node port will do is it will say that, okay, what I will do is instead of allowing only people who has access to Kubernetes cluster, what I will do is I will say, because the service is of type node port mode, I can allow access to people who has access to this worker node 1 or worker node 2 or worker node 3. Okay. So whoever can access the worker node IP addresses, like let's say these worker nodes are EC2 instances. Okay. So whoever has access to the EC2 instance IP addresses, they can access me. Okay. So the first case is if you create a load balancer type, then anybody in the world can access it. If you create a node port type mode, then anybody who has access to worker nodes or the EC2 instances traffic or the VPC traffic, they can have access to the pods or the applications. And in the third case, that is cluster IP mode, then nobody has access to it. Even if you have access to the VPC, even if you have access to the EC2 instance, only if you can log into this Kubernetes cluster and if you have access to the network inside the Kubernetes cluster, that is you have access to the container network, or you have access to Flannel, Calico, whatever you have configured, only they can access. Okay, so these are the three things. This is how a Kubernetes service works. So what are the three advantages if we go back? So the first advantage that Kubernetes service offers you is load balancing. Second advantage that Kubernetes service offers you is service discovery. Third advantage is exposing the applications to the world. So I explained each and everything using examples, and I hope you understood it. Like, understand right from here. If you have not understood the video, go back to this specific slide where I have explained what happens if you don't have a service in Kubernetes. Watch the video one more time. You have the auto healing capability that deployment is giving you. Why you need a Kubernetes service? I clearly explained here. That is, the IP address will get changed whenever a container comes up. If you have configured auto healing, so a new pod comes up, but the IP address has changed. So you need a discovery mechanism, and to manage the traffic between the pods, you need a load balancing mechanism. Similarly, if you want to make these applications available to internet, available to specific people in your organization, like probably you want everybody in the world to access this application if it is a open source application, or if it is application that you want everybody to access. Okay, so for example, best example is Amazon.com. Okay, so here if we go back to this slide, when will you choose cluster IP mode, when will you choose node port mode, and when will you choose load balancer mode? For example, Amazon.com. Let's say we are working for Amazon. Okay, and if as a DevOps engineer, if you have to understand services in a very simple words, if you are working for Amazon.com, what you will do is you will create a service of type load balancer. This is just example, guys. Okay, so that anybody in the world can access Amazon.com. Okay, there is one application, let's say, that is called Amazon.com. So if you create a service of type load balancer, then everybody in the world can access this. If you create, so Amazon.com is a load balancer, don't get confused, I'm just giving it as an example. If you want people inside your organization or people who have access to your VPC, your nodes, right, only those people to access, then you will create service of type node port mode. If you want only DevOps engineers, or if you want only people who have access to your Kubernetes cluster network, then you will create cluster IP mode. Take this as an assignment. Try to write few lines. Try to see, if you understood the concept well, try to draw a diagram for this, and post it on your LinkedIn, post it on your GitHub. So this is how you can correct your understanding, or you can see if your understanding is right or wrong. I hope you enjoyed the video. If you like the video, click on the like button. If you have any questions, put that questions on the comment section. Also, if you have any feedback, share that with me. Finally, don't forget to subscribe my channel, Abhishek.Veeramalla, and share this with your friends and colleagues. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.